Hello, class. Welcome to the next lesson in 8th grade Eureka Math. We're in Module 4, and we're working on Lesson 10 today. Lesson 10 is called Proportional Relationships, and you should recognize proportions because we talked about that a few lessons ago. I believe it was Lesson 7 or 8 when we talked about proportions. Well, we're going to revisit proportions again today, so you'll need pages 93 to 103 of your Module 4 workbooks. Go on and tear those pages out so that you have the freedom to work on them, and get some pages out for your notes, either in a notebook or loose leaf pages. And let's start the notes right now with our vocabulary for today. Today we have 4 vocabulary words. The first one is proportion, which we saw before. I believe it was in Lesson 7, maybe Lesson 8. I can't remember off the top of my head. But a proportion is 2 equal ratios or fractions. 2 equal ratios or fractions. So remember, a proportion looks like 2 fractions with an equal sign. That's a proportion. We're going to be seeing those today. In fact, we're going to be writing proportions today to solve some problems. And the problems are going to be about things like speed and rate. So that's why our second word is average speed. Average speed is the total distance of a journey divided by the total time. Now, this is different from instantaneous speed. Instantaneous speed is how fast something is moving right now at that instant. Average speed is total distance divided by total time. And the reason we talk about average distance is because on a trip, your speed changes. If you think of it like driving in a car, when you're pulling out of the driveway, you're going pretty slow. When you're going down in your neighborhood, you're going a little bit faster. When you get out on the main streets, you're going a little bit faster. You hit a stoplight, you stop. You get on the highway, you're going super fast. So your speed is always changing when you travel. So instead of trying to think about all the different speeds all over the place, we figure out average speed when the trip is done. We take how far you went and divided by how much time it took you. And that tells you the average speed for the whole journey, about how fast you went, how fast it took you if you were going constantly. How fast will you be going? Next vocabulary term is constant rate. Now, a constant rate is a change that stays the same. For example, if you are always walking at 3 miles an hour, that is constant. That's a constant rate. 3 miles in 1 hour is constant. Another example of a constant rate is like 4 quarters for $1. 4 quarters is always going to be $1. That rate is constant. 1 math lesson every day. That is a constant rate. We do 1 math lesson a day, always. That's constant. It's a change that stays the same. Our last vocabulary term is kind of like constant rate, only this time it's constant speed. Constant speed is a special kind of constant rate that talks about speed. Constant speed means you're not slowing down and you're not speeding up. Not slowing down, not speeding up. Your speed is constant. Your speed always stays the same. It means you hit no bumps, you don't go faster downhill, it means you don't hit any stop signs. Your speed is always the same. So it's kind of like constant rate, but it's specifically about speed. And so those are the 4 vocabulary terms that we're going to find in our lesson today. You can pause the video if you need to copy down any of those terms. If you ran out of time to copy down the definitions, pause the video now and write down what you need to write down in your notes. But I'm going to keep going because I want to talk about what we're doing today. Today we will write proportion equations. So we're going to write equations like we've been doing in Module 4. Only these equations are going to be proportion equations. They're going to start as proportion equations. And then we're going to solve them because we're going to write the proportion equations to solve problems about rates and speed. So we're going to see some real world problems about different rates, about different speeds that we want to find a solution for. And so to find these solutions, we need to think about proportions. To solve the problems, we need to write proportions and turn those proportions into solutions. So we're going to solve proportion equations to answer questions about rate and speed. So let's get going. Our example today is going to be on page 93. It's actually the first page of your lesson today is the example page. And we're going to talk about, we're going to see, we're going to explore, we're going to talk about how things work using that example page. So let's begin. Make sure you follow along carefully today because there are a lot of steps in the work. And you need to kind of do the steps in order for it to be a logical progression and to understand what we're doing to go from what the problem to our solution. There are multiple steps. So let's look at page 93, right? And there it is right there. Page 93, example 1 is a chart with a problem. So it says, Paul walks 2 miles in 25 minutes. How many miles can Paul walk in 137.5 minutes? So this right here, 2 miles in 25 minutes, that's Paul's speed. That's his average speed. That's the average speed. That's how long it takes him to do 2 miles. 2 miles in 25 minutes. How many miles can Paul walk in 137.5 minutes? Well, for this problem, we're going to assume that Paul's speed stays constant. That he doesn't slow down, he doesn't speed up, he doesn't stop for an ice cream. He always does 2 miles in 25 minutes. So 25 minutes means 2 miles. So we're going to say Paul's speed is constant. Paul's speed is constant, which means it's not going to change. So one way we can do this is we can fill in kind of a chart like you see in front of you. We know that in 25 minutes, Paul walks 2 miles because it says it right here. Well, what about in 50 minutes? How far can Paul walk in 50 minutes? Well, remember his speed is going to be constant. So if in 25 he does 2 miles, 25 times 2 is 50. So we do 2 times 2. So if in 25 minutes he does 2 miles, in 50 minutes he does 4 miles. So every 25 he does 2 miles. So if he walks for 75 minutes, well, 25 times 3 makes 75. So 2 times 3 means that he will walk 6 miles in 75 minutes. Remember, 75 is 25, 25, 25. That's 3 25s. So we do 3 2s, which is 6. What about 100 minutes? In 100 minutes, well, Paul, that's 4 sets. 25 times 4 makes 100. So 2 times 4 is he does 8 miles in 100 minutes. What about 125 minutes? Well, you should notice the pattern by now. When we go up 25 on this column goes up by 2. So plus 25, we do plus 2 and get 10. I'm going to add another row. How many miles does Paul walk in 150 minutes? Well, we do plus 25 again. So on this side, we do plus 2. He does 12 miles in 25 minutes. So you can see this side we did plus 25, plus 25, plus 25, plus 25, plus 25. This side we did plus 2, plus 2, plus 2, plus 2, plus 2. That is what we call a constant rate. This is the vocabulary term, the constant rate. It is changing, his time and the distance is changing, but the rate stays the same. It always goes up 25 on this side, always goes up 2 on this side. So we can make a chart just like that to help us solve the problem. But the difficulty with this is we need to find out not 50, not 75, not 100, not 125, not 150. We want 137.5. We want to figure out how far he walks in 137.5 minutes. Well, that's painful because it's not on our chart already. Now we know where it's going to be. It's 137.5 is in between 125 and 150. It's going to be somewhere in the middle, which means our answer is going to be somewhere in the middle right here. So if 137 is between these numbers, the answer is going to be between these numbers. But we just can't guess. We can't just pick a number in the middle. We're going to use our math. We're going to make a math equation to find it exactly. So the first thing we're going to do is we need to think about what we know. This is everything we know. We know he does 2 miles and 25, 4 and 50, 6 and 75, 8 and 100, 10 and 125, 12 and 150. And we know we need to find 137.5. So that's what we know. Now what we don't know. We do not know the number of miles in 137.5. So we don't know that. So let's put a variable. It's going to be x. That's our unknown. That's our variable. So let's just focus for a minute on the top two lines. The top line and the bottom line, I'm sorry. We know he does 2 miles in 25 minutes. We need to figure out how many miles in 137.5 minutes. And this is our missing piece of information. The x is our missing piece of information. We also know that it changes the same way. It's always changing the same way on this side, and it's always changing the same way on this side. So because both sides change the same way, that's a proportion. It's a fraction that we can write. So we can take, and we can say, okay, 25 minutes means 2 miles. And because these are proportions, because they change the same way, we know that this is going to be equal to 50 in 4, 75 in 6, 100 in 8, 125 in 10, 150 in 12. We know all of that's going to be equal. In fact, if you're good at reducing fractions, you know this. Because 50 and 4, if we divide by 2, we get 25 over 2. On this one, if we divide by 3, we get 25 and 2. Divide by 4, divide by 4, divide by 5, divide by 5. Divide by 6, divide by 6. So all of these fractions are equal. And the fractions came from our chart. 25 over 2, 50 over 4, 75 over 6, 100 over 8, 125 over 10, 150 over 12. All of these are equal because they changed the same way. They changed the same constant rate. So if all of these are equal, it means that this is also equal because it came from the chart. We know that this has to be equal. We don't know what x is, but we know this is going to be equal. Now we have a proportional equation. This is a proportion. We know 25 over 2 equals 137.5 divided by something. Now we just need to find the something to know how many miles he went. Now this should look familiar. You know how to solve this. You're going to use the multiplication property of equality. Remember, the multiplication property of equality simplifies our proportions so they're easier to solve. And we do this by multiplying by x and 2 on both sides. Because multiplying by x and 2 on this side, the 2's cancel. So we keep 25 and x. And on this side, the x's cancel. So we keep 137.5 times 2. The multiplication property of equality simplified our proportion. Now we want to solve that part right there. Let's multiply first to get a constant, one constant on that side. We get 25x equals 275. Equals 275. Now remember, we only want the x isolated. So we use the division property of equality, divide both sides by 25. And 275 divided by 25 is 11. That's our answer. X equals 11. So we know now that when x equals 11, that x equals 11. So it means that in 137.5 minutes, Paul can walk 11 miles. So that's how we find our solution. In 137.5 minutes, Paul walks 11 miles. And that's how we solved it. Let me show you again how we solved it. First, we filled in the chart and we found out that all of these fractions are equal. 25 and 2 is equal to 50 over 4, equal to 75 over 6, equal to 100 over 8, equal to 125 over 10, equal to 150 over 12. All of these are equal. And then we said, well, if all of those are equal, then we don't know this number, but we do know that 25 over 2 does equal 137.5 over what's missing, x. So we built a proportion. Then we solved the proportion. We start with the multiplication property of equality. We solved our proportion to find the missing solution. So we started with Paul's constant rate, 25 over 2. We used that to find what was missing. Start with what you know, find what you don't know. So that's our example. Hopefully you follow along and you understand what we're doing, but we are going to practice it some more. So let's go to the next page. Let's go to page 94 and let's look at number 1, because the good thing about this lesson is they walk you through everything step by step. They take you step by step. They tell you everything that you have to do in order. So let's work on exercise 1 together. I believe, let's see how many exercises we have. We have exercise 1, 2, and 3. So there are 3 exercises. Let's work on exercise 1 together, and then I'm going to want you to try yourself on exercise 2. So exercise 1. Wesley walks at a constant speed, which means his speed does not change, from his house to school 1.5 miles away. So he walks from his house to school 1.5 miles away. It takes him 25 minutes to get to school. Okay. Now, what fraction represents his constant speed? Well, constant speed, let's do capital C for constant speed. Constant speed is distance divided by time. So his constant speed is distance divided by time. So this is important right here. Distance divided by time is speed. So what fraction is his constant speed? Well, Wesley's distance to school is 1.5 miles, and his time is 25 minutes. So that's his constant speed. That's his constant speed. That's the fraction he needs. We know this is true. This is just a fact. He does 1.5 miles in 25 minutes. That's all it's asking you for. Just write down his speed. You do not have to divide. You do not have to simplify. This is all you write down. 1.5 miles in 25 minutes. When it asks what is his constant speed, it's asking how fast does Wesley go? Wesley goes 1.5 miles in 25 minutes. 1.5 miles in 25 minutes. That's his constant speed. That's all you have to write down. That's just we just start part A. What do we know about Wesley's speed? Now let's look at part B. You want to know how many miles he has walked after 15 minutes. So how many miles in 15 minutes? So let y represent the distance he traveled after 15 minutes of walking at a given speed. Okay, so what is his speed? What is c equal for 15 minutes? Well, we know the time, remember, time is in the denominator, is 15 minutes, but we don't know how many miles that is. But it tells us, use y. Y represents the distance. So the time is 15 minutes. Remember, speed is distance over time. That's our important to remember. So the time is 15, and it says, let y be the distance. So y is the distance. So that's the answer for this. His speed is some y distance in 15 minutes. So what do we know? We know he does 1.5 miles in 25 minutes. And we know we're looking for 15 minutes, and it's going to be y. Well, part C says, write the fractions as a proportion. Write the fractions as a proportion. So we know that Wesley's speed is constant. So we know the speed from part A is going to equal the speed for part B. Because remember, it says it's a constant speed. So we know the two C's equal each other. So we know 1.5 over 25 is going to equal y over 15. We know those are equal. So that's writing it. Now we wrote the fractions as a proportion. Now it wants us to solve the proportion. Find y. How many miles does he walk in 15 minutes? Well, remember, we're going to do the multiplication property of equality, where the 25s cancel on the left, the 15s cancel on the right. So we get 15 times 1.5 equals 25y. 15. So what we're going to do, and then what we have to do now is we're going to do 115 times 1.5, which is going to be 22.5 equals 25y. Then we're going to divide by 25 to isolate the y. And you might want to get a calculator for this. But if we do this, we find out that 25y divided by 25 is 1y. And 22.5 divided by 25 is 0.9. So we know in 15 minutes, Wesley goes 0.9 miles in 15 minutes, because that's what y was. Remember, in part B, it was y miles in 15 minutes. Now we know y is 0.9, so we know he goes 0.9 miles in 15 minutes. So that's the solution. Now we figure out, we know this is Wesley's average speed. This is Wesley's speed for 15 minutes. We put them equal, and we found out how far he goes in 15 minutes. Now for part D is going to be something a little bit different. It says, let y be the distance in miles. So y is the distance. And remember, the speed is distance divided by time. So y is the distance. So y is in the numerator. And x is the minutes. So y is the distance in x minutes. So x is the time. Now we don't have any numbers. Y is the distance, x is the time. And now we need to write an equation with two variables. Two variables means x and y. We have x and y, that's two variables. to find out this. So we need to write an equation with two variables. Well, let's use our constant equation. Let's use from part A. We take the equation from part A, which we take the fraction from part A, which remember is 1.5 over 25. Because we know Wesley's missing speed is going to be proportional to the speed we know. But we can take this information, y over x equals 1.5 over 2.5, because distance over time equals distance over time. Distance divided by time, even if we don't know what it is, we know it has to be equal. Why do we know it's equal? Because Wesley's at a constant speed. It's a constant speed. It tells us in the question that it's a constant speed. So we know this distance and time equals this distance and time. And now we can use this proportion, these two fractions, to find an equation. We're going to solve it just like we did part C. We're going to do 25 times x on both sides. Because on this side, the x's will cancel, and on this side, the 25's will cancel. So we get 25y equals 1.5x. That's a linear equation that will tell us that is true. We know it's true because Wesley's at a constant speed. So these fractions have to be equal. So these expressions have to be equal because we just simplified. Now, usually one thing people like to do when they're writing these math equations, when there's two variables, remember this is two variables. We have x and we have y. When we write equations like this, people just like to have y equals something. They just want one variable but isolated on one side. That's just what people do for when they write math equations. When they write math equations with two variables, it's always, or most of the time, y equals something. So we're going to divide by 25 on both sides, the division property of equality, to isolate the y. So we get 1.5x divided by 25. I'm just going to leave it like that. So the equation is 1.5 divided by 1.5x divided by 25. So this is our equation with two variables. Now, why did we make an equation like this? Well, let me tell you, because part A only tells us 1.5 miles and 25. Part B is a question, y over 15. Part C only works if we want to find 15 minutes. Part A, B, and C work together if we want to find how far he goes in 15 minutes. But the equation we wrote for part D is super helpful because now we can use any minutes for x. This is an equation that helps us with any x. Part C only helped us with 15 minutes. Part D, we can find however many minutes we want. We can find out how far Wesley walks in 17 minutes, in 22 minutes, in 42 minutes, in 198 minutes. Because x is a variable, we can pick whatever minutes we want. So C helped us find 15 minutes. D helps us find any minutes we want. And that's why we write the equation for part D. So that we have an equation that we can use for however many minutes we want. That's the purpose of two variable equations. A two variable equation helps us find any x we want. Part C only works when it's 15. Part D will work for anything. So it's much more useful. So I know it was a little bit tricky on the exercise. So the first thing we did, we just wrote down what we knew in part A. We just talked about Wesley's speed that we know. Part B, we wrote down what we want to know. We know in part A he goes 1.5 miles in 25 minutes. Part B, we want to find how many in 15 minutes. Part C, we used a proportion. We put them equal to find how many miles in 15 minutes. And part D, we made an equation for any minutes we want. All of this is connected. It all makes sense. It's all super useful. Hopefully you follow along. If you do not, you can go back and watch it again. But what I would like you to do right now is try it yourself on exercise 2. Exercise 2 is going to follow the same pattern. You're going to write down what you know for part A. This time it's Stephanie. What is Stephanie's speed that we know? For part B, write down what we want to know. For part C, find what we want to know. And for part D, write a 2-variable equation that can be used for anything. So pause the video, work on number 2, exercise 2 on your own. Unpause the video to check your answers with mine, because when you unpause, I'm going to solve it my way, and you can check your work with mine as I explain. But pause right now and work on number 2, and work on all of number 2, part A, B, C, and D. But I'm going to keep going, so hopefully you finished number 2, A, B, C, and D, and you're ready to check your work now. Okay, let me go. Stephanie drove at a constant speed from her apartment to her friend's house 20 miles away. It took her 45 minutes to reach her destination. What fraction represents her constant speed? C. So I remember speed is distance over time. So Stephanie's speed is going to be Stephanie's distance over time. So I know her speed is the distance she went, 20 miles, divided by the time, which was 45 minutes. So that's what I know. Stephanie's speed is 20 miles in 45 minutes. That's what I know. Let me go to part B on the next page. So you should have got this. Check your work. That's her speed. Let's see how you did on part B. What fraction represents her constant speed if it takes her X number of minutes to get halfway to her friend's house? So we have X minutes and we're going halfway. So still, speed is still distance over time. But this time, what is her speed for part B? Well, we know it's X minutes, so her time is X, and halfway to her friend's house. Well, halfway, let's see. Her friend's house is 20 miles away, so halfway to her friend's house is going to be 10. So this time, her speed is 10 miles in X minutes. So we know she does 20 miles in 45 minutes, and she does 10 miles in X minutes. So what we need to do now for part C, and by the way, if you got part A and part B, you're doing a great job. Part C says write and solve a proportion using the fractions to find how far to the halfway point. So I'm going to take, I remember C equals C because she is at a constant speed. Right here in the question it says she's at a constant speed. So because it's constant, I know her speed in part A equals her speed in part B. Speed in A equals C in B because it is constant. The constant is the important part. So I know that 20 over 45, 20 miles in 45 minutes has to equal 10 miles in X minutes. And I can use this proportion to find how many minutes to get to the halfway point. Again, I'm going to use the multiplication property of equality to simplify this proportion. I wrote a proportion. I need to simplify it. So I'm going to do X times 45 times both sides. Because on the left side, I get to cancel the 45s. On the right side, I get to cancel the X's. So on the left side, I keep 20 and X. On the right side, I do 10 times 45. Well, I can do that in my head. 10 times 45 is 450. So now I know 20X is 450. Now I can use that to solve to find x all by itself. I do that. I know 20x divided by 20 is 1x. Division property of equality tells me I have to do both sides divided by 20. And when I do that, I get 450 divided by 20. You should have gotten 22.5. So, which means x is 22.5. So it takes Stephanie. Stephanie takes 22.5 minutes to go 10 miles. That's my answer. 22.5 is x, and if you look at again at part B, 10 miles in x, so 10 miles in 22.5 minutes. So you see how finding the constant rate that we know in part A, thinking about the constant speed that we're missing a part of in part B, building a proportion and solving the proportion helps us find the missing piece, helps us solve the puzzle, helps us solve the problem. But for part D, again, it's asking how many miles in any time, which means we need, for speed of D is going to be y miles in x time, because we don't know miles, and it could be any time we want. So y divided by x. So I need to write an equation that shows me any miles I want, y over x. Well, again, because Stephanie's speed is constant, I know that C of A is going to equal the C of D. It's equal because it's constant. It's constant because it tells us so. It has to stay. You have to see the word constant speed for this to work. So I know that 20 over 45 is going to equal some distance y divided by some time x. But this is a proportion. I can solve this proportion, remember, by multiplying the denominators of both sides, so that I cancel the 45 on this side, I cancel the x on this side. So I get 20x equals 45y, which is an equation I can use to find any x and y I want. But also remember that usually in math, people like just y equals something. So we're going to divide by 45 to isolate the y. So we get 20 over 45 equals y. Now you might have gotten that. If you did it well, you got this. But so we get y equals 20 over 45x. So I forgot to keep the x. So that's our equation in two variables. So now I can put whatever x I want and find y. Or I can put whatever y I want and find x. That's why we have two variable equations. So we can solve this problem for any numbers we want. I am going to simplify this fraction though, because 20 is 5 times 4 and 45 is 5 times 9. So I can so the 5 divided by 5 is 1. So my final equation is going to be y equals 4/9. That's what I'm going to write because it's a simplify. Now, maybe you forgot to simplify. Maybe you kept y equals 20 over 45x. Remember, this is a good answer, but this is the best answer. Simplified is always the best. So that was your work. Hopefully you did a pretty good job on it. Let's summarize what you did. You wanted Stephanie's constant speed for 20 miles, and in 20 miles, her speed is 20 miles in 45 minutes. That was part A. Then you wanted her speed for 10 miles, halfway, 10 miles in x, because we don't know x. 10 miles in x was her halfway speed. And then we took the two fractions, 20 over 45 and 10 over x, and we know they're equal because he's constant. And we built a proportion to find x. So we built a proportion, solved the proportion, found x. So we figure out how long it takes her to go 10 miles. And then for part D, we built an equation to use for any time and any miles. So that's what we're doing today. That's the work that we're working on. We have one more exercise to do. This is exercise 3. It says use the equation. This time they gave you the equation. So this right here is our equation in 2 variables. So they've made the equation for us already. So this equation tells me how many miles in y Dave is away from time A for any hours x. So x is hours, y is the distance. So x is time, y is distance. And we can use this equation. So in 1 hour, Dave is 65 miles away from town. In 2 hours, we use the equation. So x is going to be 2. Y is 50 times 2 plus 15. 50 times 2 is 100 plus 15. Y equals 115. So in 1 hour, Dave is 65 miles away. In 2 hours, Dave is 115 miles away. In 3 hours, we use the equation again. Y equals, remember, that's why we love these equations, is why we're learning to make them. Because this equation can be solved for all, we can use this equation to solve all of these. Y equals 50 times 3 this time plus 15. 50 times 3 is 150 plus 15. 150 plus 15 is 165. So in 1 hour, Dave is 65 miles away. 2 hours, Dave is 115 miles away. 3 hours, Dave is 165 miles away. In 3.5 hours, even though it's a decimal, we can still use the same equation. That's why these equations are amazing. We just do 50 times 3.5, which is 175 plus 15, which is 190. So in 3.5 hours, Dave is 190 miles away. What about 4.1? Even like a kind of an odd fraction like that, we use the same equation, 50 times 4.1 plus 15. 50 times 4.1, I believe is 205. 205 plus 15. 205 plus 15 is 220. So in 4.1 hours, Dave is 220 miles away. So for exercises 1 and 2, we showed you how to make these equations. In exercise 3, I show you why these equations are super helpful. Because we use one equation to find 5 different answers. One equation gives us 5 different answers. So that's why knowing how to make these equations is so valuable. It's so good because it helps you find for anything. So maybe on Monday, Dave drives for 3 hours. We have that answer. Maybe on Tuesday, Dave drives for 1 hour. We know that. On Wednesday, if Dave drives for 3.5, we can find that. If on Thursday, Dave drives for 9 hours, all we do is use the equation again, and we can find for 9 hours. So the equation is super useful, not just for finding speed, but for all sorts of things that we're going to be working on for the next few lessons. So knowing how to write these equations, finding the equations is important. And the way we do it is by using proportions. Proportions give us the equations. Let's talk about what the work is going to be like for you today. You're going to keep practicing this, making proportions to make equations. You're going to make proportions to solve equations, and you're going to make proportions to make more equations. The lesson summary is on page 96. You can read that. Shows you what speed is. So like right here we say y over x, which is distance over time, is speed. Exit ticket is on page 97. Let's shuffle that to the back so we can work on that last. Page 99 is the start of the homework helper. They give you another example for the homework helper. This time, Jurgen is writing a paper, 12 pages in 66 minutes. So you find his speed, and you find out how many pages he types in 24 minutes. And then part C, it tells you he types 4.36 pages in 24 minutes. And then they make an equation for how many pages he types in however minutes. Like X is unknown, so this works for any number of minutes. So look at that equation again for another example about how to take what you know, take what you want to know, make a proportion to solve, and make a proportion to make an equation. So proportions to solve and proportions for equations. That's what we're doing today. It's all about proportions. And there's another example, another homework helper problem on page 2, same thing. I mean, number 2, same thing. Number 3, same thing. Number 4, homework helper, they gave you 4 homework helper problems just to make sure you know what you're doing. So look at the homework helper if you get even a little bit confused, because this is super important. And then page 103 is your problem set, and there are 5 questions on the problem set. And they squeezed all 5 questions onto one page, so you don't have a whole lot of room. So I expect your work to be on a separate piece of paper. So do your work on a separate piece of paper. And then remember, the problem set, I put my answers to the problem set online. I put my answers to the problem set. I put my work for the problem set on the Google Classroom. So look at my answers, look at my work, and check yours with mine to make sure you are doing it right. And if you have any questions about this, remember to ask me. I want to help you. You just have to ask. But number 1, 2, and 3 are going to be exactly what we did in the work. In fact, all of this is going to be working with proportions to solve, and for A, B, and C, and part D, making an equation using a proportion, a 2-variable equation with a proportion. So just do your best on these. Check your work with mine. On number 5, you have a chart. It's exactly what we did on the exercises today. I know if you were paying attention, you could do this, but if you have any questions, I want to help you. Just ask. When you finish the problem set and you check your work with mine and you feel good doing what you're doing, then go back to page 97 and work on the exit ticket, which is the same thing. Part A, you're going to write the fraction for Alex's speed. Part B, the speed and making a fraction for what you want to know. Part C, finding the answer. So A is what the speed you know, B is the speed you want to know, and C is making a proportion to solve. Do your best, have fun with it, work hard, ask me questions if you get stuck, and I will see you for the next lesson.